Good morning, grade fours, and welcome to Natural Science. It's good to see you again, and it's awesome to be with you, and it's always great to be your science teacher. Remember that throughout this lesson, if you've got any questions, email them to grade4@worksheetcloud.com. So today we are going to do something I think very cool, and it fits in exactly with our theme, and it's just so nice to learn more about places around the world. So as you all know, this theme that we are on an adventure with is all about planets and the solar system and Earth and just learning about our little universe. Okay. But before I go into that, and before we do our starter activity, which I think you're going to enjoy, I have a question for you. What do you call a tree that fits in your hand? What kind of tree fits in your hand? What kind of tree does that? Well, if you said a palm tree fits in your hand, then you are correct. So well done. So what kind of tree fits in your hand? A palm tree. Awesome. Right, so last lesson we looked at the surfaces of Earth, particularly the land, air, and the water. And today we are going to learn about the sun, right? And so this is today's lesson. But before we actually learn more about the sun, because the sun is very, very interesting, as a warm-up, or shall I say starter activity, I thought we can go on to a little journey on Google Earth. So for some of you that have used Google Earth before, it is an amazing program, and we have an Earth over here, and what it does is we have, if I'm going to feel lucky, and that is going to take me to any part of the Earth, and let's see where it takes us. So we are going to go to Mount Telang. I'm probably saying it wrong, but let's have a look at what this mountain looks like. How cool is this? Right, have a look at this mountain. We can see the 3D parts of the mountain. It's busy loading over here as we get to see this mountain. And at the start of every lesson, we are just going to explore our Earth, and we're going to go to these different places. We can't physically go there, but using Google Earth, we can. So let's have a look at this mountain. Should we zoom up a little bit on this mountain before we read about this particular mountain? So let's zoom up and have a look a little bit closer. See what this mountain entails. And the closer I get, the more clear it's going to become. Right, sometimes you just have to let it load as the satellites are picking it up. So this we have is Mount Telang. Should we read about it? Where exactly is this? So Mount Telang is an active stratovolcano in West Sumatra in Indonesia. So have a look at this volcano and look at the city that it surrounds this particular volcano, or this Mount Telang. Let's have a read a little bit more. I'm going to click into it, and it's going to take us to Mount Telang. Right. So Mount Telang has two crater lakes on its flanks, so on its side, the largest of which is 1 by 2 kilometers wide and is called Lake Telang. According to the Smithsonian Institution Global Volcanism Program, Mount Telang has had 8 confirmed eruptions between 1833 and 1968. Okay, that is very cool. So I did not know that, and I hope that this is something that you have now learned, and like I've said to you before, we live in the most incredible planet, and there's so many parts of our planet that I don't know. I did not know about Mount Telang in Indonesia, but now I do. And so every lesson I'm going to say feel lucky, and we are going to explore somewhere cool, somewhere new, somewhere on this planet, and just learn something new. Okay, and so that is the start or our little activity for today's lesson. So let's go back to our lesson on the sun. Let me present and let's get going. Right, so the sun, for those of you that possibly did not know, the sun is not a planet. The sun is actually classified as a star. It is a star, and the sun looks big to us. So if you look at the sun and you compare it to all the other stars, because you're probably thinking, but Miss Kun, if we look at the sky and we see the stars are tiny in the sky compared to the sun. The sun is really big. So how can the sun be a star if it's much bigger than all the other stars that we see? Okay, now remember that the sun looks big. The sun looks big, but it's only because it is the closest star to us. All those other tiny little stars that you see, they are much further away to Earth than what the sun is. And so we see the sun as much bigger because it is closer. Okay. And so compared to all the other stars in the universe, the sun is actually considered to be an average size. So can you believe it that there's actually stars out there in the universe that are much bigger than the sun? And there's also stars that are much smaller. But when we talk about an average size, if we have to look at all the stars collectively together, most of them would be about the same size as the sun. So it also says over here, the smaller stars are less than 1/10 as massive as the sun. So if you have to take the sun and cut it up into 10 pieces, so now we're introducing a little bit of fractions. So if we cut the sun up into 10 pieces and we only take one of those little pieces, some stars are as small as those one pieces. Whereas on the other side, the biggest stars are more than 100 times as massive as the sun. We take that sun, our sun, and we times it by 100. Can you imagine how big that star would be? So the sun is a star, and all stars can be different sizes. And remember, the point about this particular slide is that the reason why we see the sun as looking quite big as a star, it's only because it is the closest one, the closest star to us on Earth. Right. So just looking again at stars, as I've just mentioned, that the stars are less than 1/10 as massive as the sun. So have a look at all this. This is a beautiful picture of the stars. And some of you, so tonight, if you're able to, it might be a little bit chilly because we are moving into winter, but go outside, have a look at the sky and have a look at the stars. I love staring at the stars at night. And sometimes for those of you that are in areas that aren't as well lit up, so if you live in the city, usually at night, because of the lights from the city, it's difficult to see the stars. But if you go away from the city and you look up at night, and it's a clear, beautiful sky, and there's no clouds, you are able to really see those stars, and they really pop out. And it is really, really beautiful. And for those of you that are interested in stars, you can try and see different constellations, and sometimes you might even come across a shooting star, which is very cool. And they always say you must make a wish. As soon as you see a shooting star, you make a wish, but don't tell anyone you wish, because as they say, it might not come true. Whether that's true or not, I don't know. Okay, right. So let's have a look here. Even though it is not considered a very big star, it is massive compared to the size of Earth. So even though the sun, as we said, is considered an average size for a star, our sun is so big compared to the size of Earth that if we have a look at the size of Earth, more than 1 million planets like Earth could fit into the sun. So the sun is so big that if we take 1 million Earths, it would fit into, more than 1 million Earths would fit into the sun. So the sun is huge. It is absolutely massive. So our planet is actually quite small in comparison to some of the other planets, as well as, more importantly, the sun. So the sun is massive, and this is just an indication to show you how big the sun is compared to us. So if you just really think about where we are and how small we are as humans, compare us and how small we are to the area that we live in, then to the city that we live in, to the province, to the country, to the continent, to the world. We are a freckle. And so if you think about the grand scheme of the world that we live in and the universe, we are tiny compared to the size of the sun. Right. Very interesting, I found. Let me move this side. Right. So sometimes I'll get this question quite often. Miss Kuhn, how is it then that the planets, we don't all just move towards the sun and then we end up melting? So how is it that we aren't singed by the sun? So what happens in this particular picture actually explains it beautifully. So the sun is the center of our universe. It's the center of our solar system. And that sun is, the different planets in our solar system are around the sun. So you can see all the different planets are around the sun, right? Here we are as Earth. We are the third planet closest to the sun. And all the planets actually are able to stay in place where they are due to the gravitational force. So just like we are able, there's gravity on Earth that we are able to stand and we don't float around in our air and our atmosphere. There's also a gravitational force in this pull that exists between the sun and the earth, the sun and all the other planets, and that pull keeps the planets in place where they are, that they're still able to revolve around the sun, but they stay put where they are in place and they don't move. Okay, so that was quite interesting for me. So if we say this, if we read this, it says, it's a huge mass produces a gravitational force for our entire solar system, which makes all other planets and celestial bodies to circle around it. If we group all the planets of our solar system together, the sun has a mass which is more than 745 times bigger. So what that means is that if you have to take all of these planets, all of the planets, you put them all together and you compare the mass of all of those planets compared to the mass of the sun is still 745 times bigger than all the planets put together. And these planets are huge, right, even compared to the size of Earth. So that is mind-blowing for me. The Earth is on the perfect distance from the sun to sustain life, because at that distance, the water which is necessary for life is liquid. So boys and girls, Earth, where we are positioned right now and where our planet is positioned, we are the third planet away from the sun. And in our little belt, so we call it a belt, so you can see that we can say that this is, look at Earth's belt and the line or how the Earth revolves around the sun. The Earth is the perfect distance away from the sun, that we still receive that heat and that light from the sun, that we can use it to sustain life, because the sun is responsible for all life on Earth. If we didn't have a sun, there wouldn't be life on Earth, because as I've spoken to you before, the solar energy that we get from the sun is responsible for the plants making their own food, and plants only exist because of the sun, right? So we are the perfect distance away for the solar energy and for life to exist on our planet, as well as, more importantly, for water to remain in a liquid form, okay? For water, because if we were too close to the sun, water wouldn't exist. It would be too hot and water would just evaporate. Or on the flip side, either it would be too hot or way too cold. Okay. So we are the perfect distance away from the sun. So what exactly, if we look at the suns, if the sun is a star, what is the star made of? What is the sun made of? So The sun is a giant ball of hydrogen gas, and it's constantly changing into helium gas. So it's almost like a mixture of hydrogen and helium gas together. And because it's constantly changing, there's a lot of energy that is given off as the gas changes from one form to the next. And so as there's a lot of energy, it gives off a lot of heat as well. And that's why the sun is so hot, because of the hydrogen and the helium gas that are constantly changing. Now, because it's so hot, the temperatures of the sun is 5,500 degrees Celsius on the surface. So that's just on the surface. That's not in the middle of the sun. On the surface of the sun, that's how hot it actually gets. So the next time it is summer, because it's not summer right now, we are in autumn at the moment. But the next time it is summer and we have a particularly hot day, usually in December and January, and sometimes I know our temperatures here in South Africa, no matter where you are, can reach well into the high 30s, 30 degrees. Just think about it. We experience 30 odd degrees and it gets really hot. The surface is 5,500 degrees Celsius. Very, very hot. Okay. So now specifically, I said to you that Earth, we are the third planet in line from the sun, and we are the perfect distance away from the sun. But when I talk about the distance, how far away is it, more or less? So have a look here. So the distance from the sun to the Earth is approximately, so I'm going to round this off, it's approximately 150 million kilometers away from the sun. 150 million kilometers. That is very far. Now, just to put it into perspective, if you have to jump into your car, and you know when you're on the highway and you see the big sign on the highway and it says that your maximum speed is 120 kilometers an hour, and that's the speed that you should be traveling, the maximum speed on the highway. If you get into your car and you travel at that maximum speed and you go to the sun, it's going to take you 146 years. That's without stopping, without having a petrol break, without stretching your legs. 146 years to get to the sun because of the distance. 149.6 million kilometers, or just round it off, it's easier to say 150 million kilometers. That is the distance from the sun to the earth and from the earth to the sun. Very interesting. Very, very far. Okay, right. And so the next interesting fact that I want to share with you is a fact about another type of star. So as I've mentioned, our sun is our star. It is the closest star to us. And because it's the closest star, that's why it looks bigger. But it's actually an average size compared to all the other stars. But what is the next closest star to us? So the second nearest star has also got a name, and its name is called Proxima Centauri. That's the name of our second closest star. Now, light from our sun takes about 8 minutes to reach your eyes, right? And that's a fact. So as the sun radiates that light, it takes about 8 minutes for it to reach our eyes. But light from Proxima Centauri takes over 4 years to reach our eyes. So that's how far away it is. So there was a particular spacecraft, and it was called Voyager 1, and it was launched from the Earth many years ago in search of different things in the solar system. And it traveled away from the sun so fast at a speed of 17 kilometers every second. So for every 1, 2, it's traveling 17 kilometers per second. So you can just imagine how quick that is. Now, they say that if this particular Voyager, this spacecraft, were to travel to Proxima Centauri, which is our second closest star, it would take more than 73,000 years to arrive at that star. So again, just boys and girls, thinking about how the distances between planets and stars in our solar system is phenomenal. It's mind-blowing. And then you sit and think of where we are in our planet compared to actually what else is out there. So it is very, very cool. So boys and girls, in front of you, you'll see a quote. And I wanted to, when I saw this quote, it was from an author that's unknown. And so when I saw this, I just wanted to share it with you because I really thought, and I wanted to end this lesson off on this quote, because not only does it involve the sun, but especially it's really relevant to our situation right now. And so the quote reads, "Even the darkest night will end and the sun will rise." And so boys and girls, this quote is a very powerful quote. And I'm going to end this lesson off on that quote, that even the darkest nights will end, the sun will still rise. So especially now during COVID-19 and during our lockdown, we can have the darkest days and we can feel very negative and very upset, and there can be a lot of negativity around us. But throughout all the negativity, the sun will always rise, a new day will come, and whatever happened yesterday, and it will never be repeated, can never happen again in the same events as it did. Each day is a new day, and we have to look at the positives, and there's many positives that is happening right now. We are seeing how humans can be so kind to one another, and there are many acts of kindness happening all around us. And so what I want to task all of you today is I want you to take a step back and I want you to think about what is a positive that is happening in your life right now. Maybe while you are at home, you're spending more time with your loved ones. Maybe you are learning more about something cool and interesting that you probably maybe didn't before. Maybe you have discovered a new hidden talent. Maybe you are being creative in some way. Maybe you're just doing something at home that you'd never got a chance to do before. So what is it that is positively affecting? What is it that COVID-19 is positively affecting you? How is it affecting you? And so I want you to think about that. I want you to focus on it. And if you are having a tough day or a tough time, remember the sun will always rise. Dark days don't last forever. The sun will always rise, but it's up to you to allow your sun to rise. So on that note, grade 4s, have a wonderful day. I will see you next time. Hakuna Matata, and remember to be kind to one another.